All right, so now, like I said, we're getting into compound interest. This is what's used on a regular basis today. Now, I want to compare the two and kind of explain the difference between simple interest and compound interest. So an example one for this day, I'm going to do another simple interest question. All right, so I've got I equals P, R, and T. All right, so again, we have a situation where I'm going to figure out some simple interest here. It says, example one, find the final amount, or the amount, final amount, same thing, in a bank account if $1,000 is invested at a rate of 8% for 3 years using simple interest. All right, so we're going to put $1,000 in the bank. All right, so there's my principal. My rate is 8%, which again, as a decimal, divide by 100%, 0.08. And we're looking at doing the time for 3 years. All right, so now I substitute in my numbers. So I have I equals 1,000 times my rate, which is 0.08, and times my time, which is 3. All right, so I multiply my three numbers, and I'm going to get that it is $240. Now that is the interest that has accumulated. Good if you're lending, bad if you're borrowing. But again, we want the final amount. And again, the amount is you take the principal, the money you put in, plus the interest you made. So in this case, our amount is $1,000 was put in, plus $240 of interest was accumulated, which, as a final number, is going to be $1,240. All right, so that's the amount that would be accumulated. Now, here's what we're getting into. That's simple interest, is that we're dealing with compound interest. And the difference with compound interest is that after a certain amount of time, say a year, the interest is added, and then the next year, you make money, if you're investing, of course, you make money on your principal, but you also make money on your interest. So your interest earns interest. That does not happen with simple interest. With compound interest, it compounds because not only is your principal making money, but your interest is also making you money. Again, if you're investing, if you're borrowing, it works the opposite way, because you're not only you getting charged interest on the principal, you're being charged interest on the interest. All right, now the formula for compound interest is A equals P, our principal, 1 plus the interest rate to the power of N. All right, so we've got some different variables here with N, which is going to be our amount of years for now. All right, A, again, is our amount. P is, again, our principal, and R is our interest rate. So the formula has a little bit different things. There's no big I, there's no interest. And so now what I'm going to do is I'm going to look at the same situation of investing $1,000 at 8% over 3 years using compound interest. All right, so I'm going to leave that up there. All right, so so this is example 2, compound interest. Same problem, only, again, I'm going to use compound interest. All right, so again, we're finding the final amount. So this formula, that's what it has, is the final amount. All right, my principal, again, I am putting in $1,000. I have 1 plus R. Well, R is 0.08. That's my rate. So in the brackets here, I'm going to have 1.08. Now, this is something that's going to change at 11 o'clock, but N is the number of times the interest is going to be added. In this question, it is being compounded annually. All right, so the interest is going to be added after every year. And so if we're investing this amount of money for 3 years, N is going to be 3. All right, because the interest is going to be added 3 times. Once after year 1, once after year 2, and then finally after year 3. All right, now I've just substituted into my equation. And so I have A is equal to 1,000. I have to follow Bedman, so I have to do my exponent first. I'm going to do 1.08, and I get to the power of 3, and I get 1.26. I multiply those two numbers, And now the accumulated amount, so I don't have to do an extra formula here, is going to be $1,260. All right, so when we use this situation and we had simple interest, the final amount was that you would say owe or be owed, depending on, again, if you're the investor or the borrower. 1240 was simple interest. But because in compound interest, your interest is also making interest, now the amount changes and you would have $1,260, a $20 difference. So is that huge? Well, it depends if $20 is a big deal to you. The more money you invest or borrow, the more that amount will accumulate. All right, so I'm going to try example number 3 here. Is there any questions about that so far? Again, just going through the difference of simple interest, compound interest. All right, let's try another one of those. Leave the formula up there. We're going to need it. All right, so now we have example number 3. All right, so it's no surprise here. We're going to use our compound interest formula. So I have A is equal to P times R plus 1 to the power of N. All right, so again, I'm just going to write down my 4 variables here. There we go. All right, so now we get the situation. It says, find the amount of interest earned, okay, if $5,000 is invested at a rate of 15% compounded annually for 6 years. All right, so we're finding the amount of interest. We're looking for this. All right, but what do we have? We do know that we are investing $5,000. That is still your principal. All right, it is at a rate of 15%. So again, I'm going to convert that to a decimal. It's going to be 0.15. All right, now it is being compounded annually for 6 years. So that means the interest is added after year 1, year 2, year 3, year 4, year 5, and year 6. 6 times, that's N, the number of times the interest is being added. All right, so here's now, I want the interest. I have this information. I can find my accumulated amount, given my formula here. And just like simple interest, your accumulated amount is equal to your principal plus your interest. Or if I rearrange this formula, I move the P over there, my interest would be equal to A minus P. All right, which I have P, now I can find A, which will allow me to find my interest. But first we'll find that accumulated amount. All right, so I'm going to plug into my formula here. So again, $5,000 is my principal. 1 plus the interest rate. Okay, so if I have 0.15 and I add 1, I'm going to have 1.15 here in brackets. All right, and then again, the interest is going to be added 6 times because it's compounded annually, which means it's going to be added after the end of every year. All right, so again, I'm going to use BEDMAS to solve my equation here. So that means I got to do the exponents first. All right, so I take 1.15 and I take it to the power of 6 and I get 2.31. All right, and then of course I multiply that by $5,000 and I end up with $11,550. So that's how much is now in the account. After investing only $5,000, you've more than doubled your money. But I want to know how much interest we made. Going back over here now. All right, so I know right now I've got my A. I've accumulated $11,550. The amount that's the amount that's in the account now. I invested, or this person invested, wish it was me, $5,000. And so if I take those two numbers and I subtract them, I get how much interest, in this case, investing, that was made. And so it's going to be $6,550 of interest was accumulated. There we go. So again, compound interest. All right, try one more of those. All right, so next up, last example, where we have example number 4. All right, again, we're going to be dealing with compound interest. So A is equal to P times 1 plus your interest rate to the power of N. So again, I'm going to write down my 4 variables. All right, and so here we go in example number 4. How much money would a student put into an account now so that there is $18,000 2 years from now, grade 11, grade 12, for their first year of post-secondary school, which is roughly $18,000, so I'm told, if the money is invested at a rate of 9% compounded annually. All right, so how much money would you have to put into an account now? So what it wants to know is how much would you have to invest? What would your principal have to be now so that you accumulate $18,000 to pay for your first year of university or college? All right, now this money is being compounded at 9% annually. So again, there's my rate, all right? So I'm going to convert it to a decimal by dividing by 100%, so it's 0.09. And what else am I missing? This is compounded annually. This is 2 years from now, and so the interest would be compounded twice. Once after the first year and once after the second year. All right, so I've got all my variables but one. That's what you need to happen to solve an equation. All right, so I'm going to substitute in. There's the amount we want, $18,000. There's our principal, the amount that we wanting to know how much we have to invest now. 9%, that's our rate, plus a 1. And so in the brackets here, I'm going to have 1.09. And because we have only got 2 years to save, like I said, grade 11, grade 12, N is 2. That is the number of times the interest is going to be added. All right, so now I'm going to solve for P. So first I'm going to figure out this exponent here first. So I got 18,000 is equal to P. Let's see here, 1.09 squared is actually 1.19. All right, and lastly, well, to get P by itself, our principal, going to divide here by my numerical coefficient. So divide both sides by the 1.19. All right, and those divide each other out. And so our principal, the amount of money you would have to put in the bank now, this is a little bit depressing, I'm sorry for this, $15,126.05. And there we go. So that's how much you would have to invest now at 9% compounded annually to have $18,000 2 years from now. Something that is the biggest thing in investing money is, it's unfortunate, is you need 2 factors that are huge, time and money. The hard part is that when you're young, you got the time, you don't have the money. When you get older, you don't have the time, but you might, because you've been working, have the money. So that's the hard part of investing, is time and money. You need both on your side, or again, being smart with interest rates and such. But again, that's compound interest annually. At 11 o'clock, we're going to step it up. We're going to do a different type of compound interest where things get a little bit tougher, but nothing too crazy, and a little more realistic, real life stuff. And we're going to talk about that again at 11 o'clock.